Good morning all of you. Welcome back to course Database Management System. So our today's topic of video is Introduction to Serializability. So in the last video we discussed about we discussed about the schedule. So we understand that the two main types of schedule are serial schedule and non-serial schedule. So and also we discuss about other types. So in this video we are going to discuss about the other types of schedule that we are not discussing in the last video. So that type of schedule we will discuss with the concept of serializability. So first of all we should understand what is the concept of serializability. So one thing is clear from the previous video that the non-serial schedule is better as compared to serial schedule because it supports the concurrent execution of transaction or parallel execution of transaction, and we know that suppose particular transactions execute in a parallel concurrent manner, then the waiting time is very less, and suppose waiting time is less, then the efficiency of system can be improved. So what is our objective? Our objective is to find concurrent execution of transaction. We want that a transaction should execute in a concurrent manner. Okay, so serializability is one of the concepts which describe the concurrent execution of several transactions, which tells you how number of transactions can be executed in a concurrent manner. This is what the main objective of a serializability. The main objective of serializability is to find a non-serial schedule that allow transaction to execute concurrently. Means we want non-serial schedule. Because what is the benefit of non-serial schedule? That transactions are executing in a parallel manner, so that waiting time is less. Okay, this is what the main aim. So to support this concept, what we required the concept of serializability. So in order to find a serial schedule for a given schedule, we will make use of concept of serializability. So in serializability we can find conflict serializable schedule and view equivalent schedule. So these two concepts are there, so that we are going to learn. So in the serializability you need to follow following rules. So what are the rules that you need to follow? If two transactions T1 and T2 only read the data item, then there is no conflict. So it is a very simple rule. So suppose two transactions are there and they are performing read operation on same data item, then there will be no conflict. But suppose two transactions T1 and T2 either read or write different data item, then also there is no conflict. That transaction T1 is reading data item A and transaction T2 is reading data item B, then there is no conflict. But suppose transaction T1 is performing read operation on A and at the same time transaction T2 intend to perform write operation on item A, transaction T2 wants to perform write operation on item A, then there is a conflict. So you should know the conflict conditions. The conditions are very simple. If you are performing read operation at the same time on same data item, then there is no problem. Even if you are performing read and write operation on different data item, then there is no problem. But suppose you are performing read and write operation on the same data item at the same time, then you may face a problem. In that case there will be a condition of conflict. So in that case conflict will occur. So next we understand what do you mean by serializable schedule. So schedule is said to be a serializable schedule if it produces same output as produced by serial schedule. So we understand the concept of serializable schedule with this particular example. So the concept is again very simple. If for particular schedule, if you want to say that particular schedule is a serializable schedule when if it produces same output as produced by serial schedule. So this is the schedule 2 that we want to check whether it is serializable or not. So condition is very simple. Suppose it produces same output as produced by serial schedule, then we say that schedule 2 is a serializable. So let's check this. So this is schedule 1, this is a serial schedule. So in this case you just imagine that the value of A is 100 rupees. So 100 minus 50, new value of A is 50. Then read the value of B, again in B plus 50. So just imagine again initial value of B is 100. So 100 plus 50. So what is the new value of B? 150 is a new value for B. And what is the new value for A? 50. So again you will read the value of A and you multiply A with 0.1 that means 10%. So 10% of 50 is what? 5. Okay, 10% of 50 is 5. So that 5 is minus from A, so a new value of A is 45. So in case of B, again you are adding. So B initial previous value of B is 150. 150 plus 5, that is 155. Okay, so 155 is a final value for B, and what is the final value for A? 45. Okay, so these are the final value for A and B. Now we want to check in this particular schedule what is the final value of A and B. So again we will do same thing. Initial value of A is 100, so 50 rupees is minus from A, so the new value for A is 50. Then in transaction T2 you are going to read the value of A. Again the new value of A is 50. 10% is 5, so that 5 is minus from A, so the final value of A is what? 45. Okay, which is same as that of schedule 1. Now we just check the value of B. What should be the final value of B? Again, so you will read the value of B here. So you are going to add the value 50. So 100 plus 50, that is 150, and again you read the value of B. So 150 plus again temporary, what is the value of temp? Again it is 5, so 155. So again the value are same. That means I can say that schedule 2 is producing the same output as that of serial schedule. Hence I can say that schedule 2 is serializable. So this is what a simple definition for serializable schedule. A particular schedule is said to be a serializable if it produces same output as produced by serial schedule. So this is what a concept of serializable schedule. Then we are going to discuss very important concept, that is conflict serializability and view serializability. First of all, we discuss about the conflict serializability. So conflict serializability help us to find the serial schedule for given schedule. Means we can tell that we can generate a serial schedule for given schedule or not. We can able to generate serial schedule for given schedule or not. Suppose it is conflict serializable. So first of all we should understand what kind of schedule is called as a conflict serializable. So again definition is given over here. A schedule S dash is said to be a conflict serializable if it is conflict equivalent to serial schedule S. Suppose consider that there are two schedules, one is a schedule S and schedule S dash. So S dash is said to be a conflict serializable, suppose it is conflict equivalent to schedule S. But when it is conflict equivalent, what are the conditions for conflict equivalent? So second condition is given, schedule S and S dash is said to be conflict equivalent if schedule S can be transformed into schedule S dash by series of swapping of non-conflicting operations. Okay, by series of swapping of non-conflicting operation. And what is the meaning of conflicting operation and non-conflicting operation? Suppose both the operations are read-read, then it is non-conflicting, but read-write, write-read and write-write, all these are conflicting operation. Only one possibility of non-conflicting operation is that between read-read operation. And again on the same data item, suppose two data items are different, that means no matter you are performing read or write write. Suppose you are performing write operation on account A and performing write operation on account B, then there is no problem. Though there is a conflict between write operation, but they are performing on different data items, that's why there is no problem. So in this case what we are telling you, the simple thing, when a particular schedule is said to be a conflict equivalent, suppose it is when schedule is conflict serializable, suppose it is conflict equivalent to serial schedule. And when it is conflict equivalent, so for that purpose, suppose particular schedule can be transformed into schedule S dash by series of swap of non-conflicting operation. Okay, so this is what important. So here conditions are given when conflict occur between two operations. If both operations should belong to different transaction, that is important. Both operation access the same data item and at least one operation is write. When there is a write operation involved, so in that case there is a possibility that conflict will occur. Now we'll check with this particular example. So this is a serial schedule and this is a this is schedule 1 and this is schedule 2. So schedule 1 is a serial schedule, and schedule 2 we want to check whether it is conflict serializable or not. So my problem statement is that I need to check whether schedule 2 is conflict serializable or not. So we have just read the condition. When we say that schedule 2 is conflict serializable, suppose it is conflict equivalent with schedule 1. When it is conflict equivalent with schedule 1, suppose I am going to swap the non-conflicting operations. Suppose I am swapping non-conflicting operation. Okay, if schedule S can be transformed into S dash. Suppose this schedule S can be transformed into this schedule by series of swap of non-conflicting operation, then I can say that this schedule is this schedule is conflict serializable. Okay, then I can say that this schedule is conflict serializable. Okay, so in this case what I am doing here, you can observe what I want to swap the non-conflicting operation. So I know that conflict occur between whether can I say that between this read A, write A, is there any conflict? No. In the same transaction there is no conflict, but conflict will occur between two different transactions. So here there is a possibility. Okay, so here we have this 3 and here we have this 3. So we can say that there is a conflict between these two operations. There is a possibility of a conflict. Sorry, there is no possibility. These are the non-conflicting operation, because here we are reading B, here we are reading A. So these 3 operations or instruction from transaction T1 and these 3 instruction from transaction T2, we can say that they are non-conflicting. So here you can see what I have done. I just swapped. I swapped here to here. First of all, I swapped here. Okay, I performed swap between these two. So here you can see that their position has been changed. Okay, their position has changed from this to this. So in this case, what are the non-conflicting operations? So here we can see this read B equals to B plus 50, write B. These are considered as a non-conflicting operation. So these 3 and these 3 considered as a non-conflicting operation. So we can change the sequence of this. So here you can see we just bring this in here and we brought down here. So there is a swap. Okay, so in this case we can say that schedule 2 is a conflict serializable. Why? If schedule S can be transformed into schedule S dash, yes, schedule S can be transformed into schedule S dash by swapping non-conflicting operation, then we can say that this schedule is a conflict serializable schedule. So we can say that this schedule 2 is conflict serializable because it is being obtained from schedule 1. So in schedule 1 what change we have done? We have just swapped this instruction. We have just swapped this instruction. We have swapped this non-conflicting operation. So we got the schedule 2. So we can say that schedule 2 is a non-conflict serializable. So this is what this is a conflict serializable schedule. Okay. So next topic is view serializability. So here we discuss about conflict serializability. Now next concept is a view serializability. So schedule S dash is said to be a view serializable if it is view equivalent to serial schedule S. This is important thing. So in this here we discuss about view serializable schedule. Okay, so conflict serializable schedule and view serializable schedule. So schedule S dash is said to be view serializable if it is view equivalent to serial schedule S, and schedule S dash is view equivalent to schedule S when if these 3 conditions are satisfied. So I am not directly going to discuss these 3 conditions. First of all, I'll just take an example, then we'll discuss these conditions so that you will understand very easily. So here we have schedule 1, schedule 2 and schedule 3. So here we need to check what is view equivalent, which schedule, whether schedule 2 is view equivalent to schedule 1, whether schedule 3 is view equivalent to schedule 1. Schedule 1 is, so here we can say that schedule 1 is not view equivalent to schedule 2, but schedule 1 is equivalent to schedule 3, view equivalent to schedule 3. So that we need to this is a statement. So let's discuss why this statement is given, that schedule 1 and schedule 3 are view equivalent, but schedule 1 and schedule 2 are not view equivalent. So for that purpose we just read the condition. For each data item Q, if transaction Ti read the initial value of Q in schedule S, then transaction Ti must also read initial value of Q in S dash. So in this case, in schedule 1, transaction T1 is reading initial value of A, but whether it is happening in schedule 2, whether T1 is reading the initial value of A, no. But in schedule 3 you find that as that of schedule 1, in schedule 1 T1 reading the initial value of A, here also in schedule 3 T1 is reading initial value of A, but in schedule 2 T2 is reading initial value. So this schedule 2 is not satisfying condition. Okay, so first condition is being satisfied by between 1 to 3, but not between 1 to 2. Now next condition, for each data item Q, if transaction Ti executes read Q in schedule S, and if that value was produced by write Q. Okay, Ti execute read Q in schedule S, and if that value was produced by write Q, operation executed by transaction Tj, then read Q operation of Ti must also read the value of Q in schedule S dash that was produced by some write Q operation of Tj. Now what is the meaning of this? So here you can see transaction T2 is reading a value of A which is produced by transaction T1. Okay, transaction T2 is reading the value of A which is generated by transaction T1. So in this case, do you find this, that transaction T2 is reading the value of A which is generated by T1? No, this is not happening. But here you can see transaction T2 is reading the value of A which is generated by T1. That means second condition is satisfied between schedule 1 and 3, but not satisfied between 1 and 2. And what is the final condition for view equivalence? For each data item Q, transaction that perform final write Q operation in schedule S must also perform final write operation in schedule S dash. So in schedule 1, final write operation is performed by transaction T2. So in schedule 2, final write operation is performed by T1. So that condition is not satisfied. But in schedule 3, final write operation is performed by T2. So hence we can say that all these three conditions are satisfied between schedule 1 and schedule 3. Hence we can say that schedule 1 and schedule 3 is schedule 1 is view equivalent to schedule 3, but schedule 1 is not view equivalent to schedule 2 because it is not going to satisfy these three conditions. So these are the conditions of view serializability, and hence we can say that schedule 3 is a view serializable schedule. Okay, what is view serializable? If it is view equivalent to serial schedule S, and these are the conditions for view serializability. So I hope you understand the concept of conflict serializability and view serializability. These are two important concepts. Based on this, there will be a numerical. So that numerical we are going to discuss in next video. Thank you.